class inheritance. So override the start, give me everything I need in there. So positioning, that's not what was used. It's called the limit value. And limit value. Because yeah, this is not the method to call anymore. There's a new method. So now alter transform is gonna take the limit transform to alter, that's from our base class, and our limit values output. So here in this is wrap down. Okay, so let's see what our wrap down component looks like. Okay, so this is our wrap down component. So it's inheriting from the base class, which gives it this value. Now I'm thinking, why isn't it? Oh, okay. So this is the that's why I wanted the base inheritance. So limits transform value, limits transform value, limits limits behavior. How does that sound? Limits trans behavior. Limits behavior. Limit behavior. I like limits behavior. Just rename that. So that's our abstract class, limits behavior. And our editor will not be an editor for Pong trans editor. It'll be a limits behavior editor. And the second parameter is for all of its children to draw as it. So all of them will now have the same base drawer. Let's remove what we don't need from here, and we can rename the class. Alright, so the control drawer so let's save and return to the scene, and we should have a different drawer here for every final behavior inheriting from our drawer. So that's the ping pong one. That's the one we're accustomed to. And here's the new one. Cool. So we can now add positional data to it. If we press play, it behaves the same because it doesn't use the method that provides the values. Okay, so it's wrapping now from 100. Let's take a look at this transform. From 100 to 100 minus. If I turn my camera this way, it might be a better perspective. So X and Z axes. The main camera's on 0. Let's do that. Let's see if we can get about 100. Yeah, those are big basis, so let's make everything a little bit bigger. I think the scaling, this is where it's gonna reveal one of the weaknesses. Oh, it just added to the scale, so it didn't. Oh, I thought it would shrink the scale back down and then change it, but it's just adding to it. Huh. Yeah, appreciate that. Okay, so here's our wrapping to 100 and back. Right, and that's being driven from its basic behavior. That's what it had before. It inherited from, don't remember the name of the class. Before it inherited from limits behavior. Okay, so now that it's inherited from limits behavior, this is the function that we can call. Actually, we need all of this. So if we need all of this, then we probably also need that. And all we need is a value to use. So then I'm gonna extract a method here. Yeah, I knew it would say that because it doesn't know how to return the yield statement. That's fine. I don't want it here anyway. I want it in the base class. We implement your start, and then you don't override the start, and in your start you call this method. Start alter transform. Okay, so start alter transform has to be an enumerator. Okay, and it has to the ping pong value changes. What's up, Sober? How's it going, man? So the ping pong value changes, so I don't think we can pass in just the value because it's updated. So we'd have to pass in a constant update of the value. Alright. So let's do that. So in inheritance, we'd have to still each class run their own update to the method until I can figure out another way to pass that stuff in. Okay, so now let's mimic this behavior in this format. So we don't need to center the bounds. We just need to set the current. But setting the current is not going to come from hard coding anymore. It's going to come from our limits trans. So that's the first thing we need to do. So limits trans have, I don't have access to that? Well, I should have access. Oh, it's called limits transform. Okay, limits transform have a couple of accessors here that we can use. It's okay, there it is. Okay, so it's a collection Turn in the transform, and the first thing that needs to be done before we're started is set the limit current to the value coming from this particular trans. So this trans is field. So if this is gosh, running into more case statements, and case statements is not very appealing to me. An inheritance and implementation of interfaces should take care of case statements. Then you have to start writing a whole lot of class structure down the chain. So I guess so this is what my dilemma is. In order for me to know what current to set, because we no longer only have access to the transform's position due to this the base class, we have access to manipulating the position, the scale, and the rotation. So we need a case statement to reflect that. The current is going to be set to that value. And the only way I can see doing that now without writing the hierarchical structure is a switch statement. Let's do that inside of the for loop. Okay, and then we have access to the position, rotation, and scaling. That way we know which value was set on the component. Scale, position, and of course rotation is the other. So for wrapping on multiple positions, that might be pretty awful. Okay. Okay, so now if it's the position, we'll go ahead and send in our trans. Trans is the cache value of the transform. Think the transform itself is a lookup property. So every time you call it, it looks up that value. So caching it here, we only look it up once. We still can't forget what we're trying to mimic this behavior for all the accessible properties. And this one is wrapping a value down. So, and that, I think that's a property. So wrap down. So it takes the limited values that's bounded, and it wraps them between the bounds. So where's limited values here? Let's see if we can get a sneak peek inside. I guess I can go to the limit base. So limits float is a hierarchical structure that comes from limits, and in turn comes from limited, in turns comes from limit, which provides the base functionality. And they're all from iComparable, so I guess you can implement a double and a decimal or whatever else Unity provides. But float and integer are the only structures that I use, so that's really all I thought I should put in here. And of course, everything's accessible. You can just override and implement your own data type, being that it's a number to provide these particular things. Though I can see, and I've thought about having a Boolean, because Boolean can can toggle and wrap. Right, I guess. But that's probably unnecessary. But that's the hierarchical structure of the class. And up until the limits flow where it actually provides some kind of functionality like wrapping and ping ponging and those type of things. Randomizing the value comes from the base class. Anyway, so we're gonna wrap down if it's the position. Well, it should already know. Look at that. I'm not even passing in the position. Right? So that being said, it takes the value that it needs in this static function. So it checks the position and it alters that transform's value. Duh. My bad. Okay, so the current, this is where problem is. Which current do you set? At the as the topmost? Yeah, which one? I think this is might be where I wanted the. Oh my goodness, this is getting ugly. These switch statements, man. Okay, so we're in the switch statement. We get the position, and then we still have to get the field ID. Case in point. Now the field ID provides the X, the Y, and the Z. Now I've tried for probably an hour yesterday trying to find some way to use bit operators to select multiple fields, whether it be the X, the Y, the X or Y, the X and Y, and I couldn't get it to work. So my solution was adding the list to where you can pick the X for one, the Y for one, and the Z for the other. And this is the mess that it creates. Of course, it's not good to code with all these switch statements. No, from what I understand about coding, the way around this is to use interfaces, and you would just be acting on that interface, and the interface itself will have the behavior that would fit in here. So this behavior would be stuck in the interface that's going to be called when this particular ID and this particular field is encountered. I've used it before, mainly in Java for Android, and I just haven't implemented any structure like this here. But that type of programming idiom, you'd say, it's used in Java. Don't see why it can't be used here. But anyway, this is the mess that we have to type over and over. So if it's X and its position, then use position. After I start slapping in all these lines, I probably see a better way out, because this is not a good way out. It's pretty awful. And then this again, we do it for the transform. Wait a minute. So the position, that's a vector, that's a vector, that's a vector. Okay, I just had an idea. So, but let me put one more case statement in place, and that way I can see if that idea might even work. So our rotation, yeah, it might. transform. That's a quaternion. Yeah, I'm gonna continue on. So, and then we want to set the scale to the default value. They don't allow you access to the global scale. I guess the regular scale, I guess, would be the global scale, and that would be associated with his parents, and that's not something you access at all. It's always called local scale, in contrary to not local position or position. This is a position in world space, and there is a local position that you can access that's specific to this script and game object under another transform. So that might be something to be wary about. So now that we finally have the current, no way, there's I'm gonna have to think of a way out of this. That is way too much code just to do this one line. This is what just happened there. Okay, so that code does this. Wow. And we still have this part to go, the bottom part. I'm gonna do it anyway. So let me continue. So when we finally get the value from the position, actually we need to break not out of this switch, not out of this switch, but we need to break out of the for loop. That doesn't work. I thought we could break out of How do you break higher and higher? Can't you get out of there? So you gotta use a flag? Hmm. Man, that is some very, very ugly code. So limit current needs to get access to the specific transforms value. Okay, so I'm going to go into the base class and I'm going to see if there's a way when the component is added, we get access to the transform, and the first selection will give us access to its specific vector. But the vector, so it's just going to store a vector that is going to be changing. And then we'll apply that vector back to the position, the scale, or the rotation, whichever one the transform field signifies. Okay, so let's start right there. So we need a vector to store our stuff. So how do I get this out? Prop. So it's a vector 3. And we'll just call it vector 3. Oh, the private should be a little. Alright, so we'll use a vector 3 and pass that in here. Oh, it did it. Cool. Okay, so this is our structure that's gonna hold everything. It should be somewhere else. Limits transform. Okay, so one more thing that's needed here is the transform. So where do we have? Okay, have a storage of it here. So create a local variable for the transform. Do it here. Okay, and that variable we encapsulate, and we'll set it on awake, and have awake I guess be virtual. That way we'll have access to this transform throughout our class. Protected might be good. Just make it a protected variable, and we'll implement in awake. So awake is also protected virtual, and let's get our transform in the awake function, and we can use that throughout. Okay, so now what I'm thinking is to get transform vector. Okay, is a protected call. Returns a vector 3 of the specific vector on the transform that's being altered. Okay, so this can just be a property we can get and set. I like property better. Transform vector. No, get transform. So we get the transform vector, and that returns whatever is caught up in this madness here. Alright? So switch on the limits value? No. Hang on. We're going to switch on the limits value. Limit current. Limits trends. Okay, so we're going to switch on the first one. So we're going to find one. And if we don't have one, then that means there's nothing set. And there should always be something set. And if you don't set one, then it won't work. So first we get the initial limits transform. The limits transform is this component here on the bottom. So the limits trans equals if the length is greater than 0, then we return the first one. Else we return we return a new one with no data. Let me write a quick empty inner class here. So that, and it will inherit from that guy. And anything I have to implement? No. Override? No. So that's cool. Constructor? No? Awesome. So now public read only. Empty transform, actually limits transform. Equals new limits transform. Okay, this should actually be in the base class for this guy. but before it's in another assembly. So getting it out of there. Putting this one in here is just a bother right now. So we'll just use it as this. So now we need our switch statement. So if limit trans, we can just switch on it. If limit trans equals, I hope I don't have to override that to get a. I think it does object for object. So if limit trans equals empty, if you're comparing objects, then we return a vector of 0. Now, hang on. I'll take this guy here and I will put it here. Right? If you don't need to write extra code, especially even if you've written it already, don't feel bad. Okay, like this, unnecessary, because I'm doing the check twice. Right? So here, if it's no good, right, then I return the 0. Else I grab the first one and we'll work with that. Okay, so now let's switch on that case. Finally. We need the transform ID. Okay, so we return here mtrans dot position, mtrans scale, and mtrans rotation. As I'm looking at that, maybe need a transform field needs local position and local rotation as selections. Or we need to return the Euler angles. Let that be calculated. And that should be it, right? Then we return a vector 0 in the default case. And we are good. So that's the getter, and we need to set the value. So it takes an input of a vector. And we're not going to be returning anything. Need our break, however. And we'll be setting the local scale, setting the Euler angles, and setting the position. Alright, so if it's position equals vector. And if it's a rotation, we'll have to convert that the vector into Euler angles, Euler whatever structure they have underneath there. And for the scale, that can be associated just like that, and that's a void, right? So now here we can set and we can get. Man, So what are we setting? We're setting the first one. We're always going to be setting the first one, at least for now, until I understand how to use whatever that I'm doing here. So we get it, modify it, and then we can set it back. Okay, so let's see how the ping pong, the one we know that's working, will utilize that. So here's the trans coming in. And so doesn't need to, here it is right here. So centering the bounds around the x, and maybe not. So let's get transform vector. TV. Okay, let's get the transform vector. So x is all we're using. We're going to need another get, because we're going to need to get the field ID. And that's the other case that was inside, which makes total sense. Okay, hang on. Let's find the wrap down. This is the case that where is it? It's tucked in here somewhere. Okay, so this case, base class, getting set. Get her? Let's go get first. So protected float get field value. And the field value it's going to be getting is from, what are we going to be passing in here? The trans vector. So it's going to be getting it from a vector. Alright, so we're going to send in the vector. Okay, well, and we need also, do we need that trans? What do you return? A vector. We only need the vector. So we get the vector if the field ID also needs the trans. How do I get the trans? Hang tight. Let's see how this works before we get ourselves in trouble. So yeah, if you're greater, and no, how about 0f? Cool. So we got the trans. We get the field ID, and we start returning items. First of all, if it's an x, we return vector x, vector y, and vector z. Vector x, vector y, and vector z. And another case of 0. Alright, so we get the field from this vector. We are going to be getting fields from this guy. How's that? Okay, and also for now, we'll be doing the same as setting. Alright, and we'll let the, that's better. That way we let each, how do we set? We just get the field now. Each of these guys will be responsible for doing their own thing. So yes, I want to get from limits transform 0 or an index, because I'd have to check here myself. Yeah, I'd rather check. So if the length of this guy is greater than 0, then we do this stuff. Or we could say if the length is equal to 0, right, or while the length is equal to 0, we can yield null. Maybe it just haven't been set yet, and it can still be set, right? And that can be right in here. So this is what's going on. Call start. This loop runs indefinitely. If it encounters the fact that there's no settings, it just waits. If there are settings, it's gonna go on through and it's gonna do this stuff first. Alright, so yeah, I think this should be a while outside, because things above need to be set, and then so while the length equals 0, yield return null. And if it doesn't equal 0 anymore, we get the first item out of the slot. Let's give it an appropriate name here. Let's put an S on these guys so they can be distinguished. Okay, so now we've got our first transform, and we need to get the X value, or whichever value is selected on the drop down. So the value is going to be, get the value from this transform at, oh, wait a minute. Hang on. This is a vector, and that's a value. There we go. So this is passed in, and it's also passed in here, and we're going to get the value from the vector. Okay, so now we have our vector, our x, y, or z, or whatever it is, and we're going to set the bounds, the center bounds, to that value. Okay, that way we have no more constraints. In this class that is going to use, this as a base, any value can be set. Alright, so we have to accommodate them all. So there we go. So 0 gets from 0. Don't need that anymore. Set the value to the center. And then we do that, the ping ponging. Alright, we have one error here. Let me comment that. Well, actually, this is the working one. No, this one's not working. This one is a nightmare that we're gonna fix. And this works. No errors. Let's see what Unity has to say about about the errors. Just smacked the mic off my head there. So ping pong okay, wrap down okay, play okay. Alright, so play okay. Ping pong. Yes, wow. Why is it moving like that? It's out of curiosity. So it's scaling the Y up and down, and it's moving the X. Or what? It looks like it's coming closer towards me and further away, like in a V, but it's actually traveling on a straight line. That's cool. Okay, so everything works though. Stop marveling at your own code. So this is how we can pull information out and put it back in without that. Wow. Okay, so we want to do this, set the current to whatever is selected. I kind of like this thingy here. Okay, so first we check. If nothing's selected, we just wait. So while if it's disabled, the component or the object, then it will stop running. Now see, this is just as it's set that for that purpose. Maybe I shouldn't disable it. I'm gonna, yeah, this is better maybe because start is only called once. To really make something like this reliable, to be called whether the component is enabled, disabled, and changed around, you would have to start the coroutine from the enable message, and you don't need to stop the coroutine on disable because if you have this flag. But yeah, there's no need to put the enable here too because all the coroutines get chopped, I think, when the component is dead. So we want to set the value. Now this has got to be much better than that. And even if you look at the difference in code that's used, it's about 3 methods long. And so, and this can clearly be fixed. It's clear to me that it could be fixed. That'll be for when I get things working properly. So next step, we need this one. So we've got the first one, we've got the second, we've got the first one, we need the second one, and it's right here. Let's grab it. You've moved up a notch. The guy's been kicked away. So we want to run on each of them when it should only actually be one for, I'm sorry, I can't take that out of there. On each of them, we don't need trans. We know where that's coming from. We want to run our wrap down. We do not need to center. But what we do need to do is get rid of this as fast as possible before it gets any more exposure to the camera. So we check on enable. I'm going to comment out this section here. And let's see if our wrap down trans works. So wrap down trans. So as of now, it should just be sitting in the coroutine waiting. Alright? So if I add something here, it might fail. or it doesn't fail because these are enumerations, so it just picks the default enumeration. So which is change position of X, wrapping down. Change position of Y, wrapping down. And Z, of course, wrapping down. So when it comes a little